So estimating minimum sample size. So oftentimes we want to know how many observations to collect prior to starting the study. If you go back and look at the examples that we did, they were all surveys that were conducted. But how many people should we go and, sample? The reason for estimating this is one, there's a concept called statistical power, which I wouldn't get into, but a practical approach would be resources. What if you don't have enough money to sample a big chunk of the population? So sometimes it is easy to kind of get a guess about the number of observations or observations of people that you survey. And that is the minimum sample size denoted by the letter N.
Is that a little high?
No,
up right above it, under the min, that little.
Oh no, simply means that min is missing.
Oh.
Absolutely.
So
So Z squared, you can either use the positive critical value or the negative. Both of them would give the same answer. Why?
It's squared.
Because we're squared. So I'll just use the positive one. Good. That's just the formula. All you have to do is find the positive critical value, square it, multiply it by 1/4 E squared. What is E? The margin of error. So in this case, E is the desired because we have not conducted the study yet. So we're just about to go perform the study. So we set a level for the margin of error. That would be the desired margin of error. We set a value of alpha, 95, 90%, whatnot. And using this formula, I can come up with a minimum sample size, minimum number of observations that I need to collect in my study. But that is a case when you don't have a preliminary estimate. Sorry, B. If you don't have a prior estimate or a preliminary estimate for P, we will use that formula. But if someone did a study in the past and they came up to you and they said, oh, I have a P hat value, let's use that information from the past.
I have a P hat value or just P?
Well, P hat is the preliminary estimate for P, right? So if someone said that, then I would use this formula. That part does not change. All that would change is we wouldn't have the full and the numerator becomes P hat times Q hat. So that is the case when someone gives you a preliminary estimate for P.
What will happen with most of the cases? Like, will you have? Well, thank you.
That's a good question. In practice, we wouldn't have a preliminary estimate all the time. And if we don't have one, we always use this particular formula. Don't even have to memorize both. If you don't know a proportion, what is a good guess that you would go with?
If you don't know what,
A proportion of something, what is a good guess?
one.
One, if something is random.
50% chance.
50-50 chance, right? So I would just assume he had to be 1/2, which would mean Q hat is 1/2. What is 1/2 times 1/2?
0.2.
1/4, that is correct too. 1/4 divided by E squared will give you that formula.
Oh, which one is better?
Unless you're absolutely confident that your preliminary estimate is near perfect, this is going to be better in practice. Are we clear? We want to estimate the minimum sample size for a study that's going to analyze the proportion of US adults who eat fast food 4 to 6 times per week. What is the success event? US adults who eat fast food 4 to 6 times per week. The desired margin of error is 3%. Prior to conducting the study, I want 3% as the margin of error. The confidence level that I intend to set is 0.9, which would mean alpha is 0.1. Alpha over 2 is 0.05. We can find the critical value easily using the calculator. And what is that value?
Yeah, 1.64 something.
So the critical value is 1.645. So if you have no preliminary estimate, what is the formula that I wrote? The sample size is simply C squared, the critical value squared, multiplied by 1/4E squared. Yes, I know that value 1.645. Is the value of E3?
No,
Why not?
because it's in percent.
What should we do then?
0.03 divided by 100.
0.03 divided by 100? Or
No,
3 divided by 100?
You asked what it was, and then you asked what should we do. So I answered both.
Very special, Alex. So E is 0.03. Don't forget to convert it, to a regular number. That's the most common mistake that students make. So after conversion, we have 0.03. Put that in the calculator and tell me what you get.
7.5.
751.53.
5 worth rounding.
We still have to round it, correct? We can't have 751 people and, half of something. So it is 752, but keep in mind, this is not the exact sample size that I'm going to say one must use. That is the minimum value, 752, which would satisfy those conditions. C 0.9, alpha 0.1, and the desired margin of error of 3%. Yes?
Yes.
What if we have a preliminary estimate? What will change?
It'd be just 1/E squared.
It'll just be 1/E squared.
No, it would
No.
be 0.75 times 0.25
Yeah,
over E squared.
never mind.
So 1.645 squared P hat times Q hat, which would be 0.75 times 0.25. Margin of error doesn't change, so 0.03 squared. What do we get?
564.
Exactly.
No, 63.65.
So that is the minimum number of people, in other words, you as adults, that we would want to survey for whatever
Check your
charity
answer,
we do.
please. Can you check your rounding? I think it's a little off.
I don't think so. So
Are you not gonna change
is
it?
it?
563.65
Oh,
rounds to 534.
it's 564. Okay,
It's Thursday.
564. So do fix that. It's bad rounding. So the minimal sample size that we require is 564 adults. So the difference being, if we use this, we get a different sample size. But do keep in mind, in practice, this is only favorable if you have a good amount of confidence in the value that you've estimated, or else you're simply making a bad assumption. Yes?
Yes.
So it's better to use that because that may or may not be correct. So, yeah.